today's episode, we shall see how to solve the problems on integration by using the standard integration formulas. So, first we shall see the definition of integration. So, integration is the inverse process of differentiation. It is symbolically represented as in this way. So, here it means indefinite integral of f of x with respect to x. Here f of x is called integrand and x is the variable of integration. Various standard formulas of integration. So in today's episode we shall use these 5 standard formulas of integration to solve the problems. So the first one is integration of x to the power of m is equal to x to the power of n plus 1 divided by n plus 1 plus the constant of integration c. Integration of dx is x plus c. Integration of k dx is equal to kx plus c, where k is constant. Integration of 1 by x dx is log x plus c, and integration of e to the power of dx is e to the power of x plus c. We shall solve integration problems by using the standard formulas. So first we shall see how to use the standard formula x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1 and solve the integration problem. So first I shall give some simple examples. So solve first one. So integration of x dx. I'll take two problems here. Second one is integration of x square dx. So we need to solve these two integrals by using this standard formula of integration. So solution. So first I'll take the first integral, integration of x dx. So now if you compare this integration of x dx with the standard formula, so it is in the standard formula it is integration of x to the power of n. So here when you compare this x dx with x to the power of n dx, so what is n here? So when you compare, here we get n is equal to 1. So applying this formula, so that is equal to x to the power of, for in the x dx, when you compare with x to the power of n dx, the value of n is 1. So according to the formula of integration of x dx is x to the power of n plus 1. What is n? N is 1. So it is 1 plus 1 divided by 1 plus 1 plus the constant of integration c. So that is equal to, here 1 plus 1 is 2. So x square divided by 1 plus 1 is 2 plus the constant of integration c. So that is the integration of x dx. This is how we use the standard formula and solve the problems. The second problem is integration of x square dx. So solution. So integration of x square dx. So when you compare with the standard formula, x to the power of n dx, that is equal to x to the power of n plus 1 divided by n plus 1 plus the constant of integration c. So when you compare it with that, so what do you find? In the place of n is equal to 2. So therefore integration of x square dx is x to the power of n plus 1. N is 2. So it is 2 plus 1 divided by 2 plus 1 plus the constant of integration c. So that is equal to 2 plus 1 is 3. So x to the power of 3 divided by 3 plus the constant of integration c. So that is how you solve that integral. Further solving some more problems of integration, we should know this rule of exponents. So all these rules I have studied earlier, so just I'm briefly writing it. A to the power of minus m is 1 divided by a to the power of m. A to the power of 1 means it's a to the power of 0 means it is equal to 1, and a to the power of m into a to the power of n is equal to a to the power of m plus n. A to the power of m divided by a to the power of n is a to the power of m minus n. A to the power of m raised to the power of n means a to the power of mn. A b to the power of n means a to the power of n into b to the power of n. A by b to the power of n is equal to a to the power of n divided by b to the power of n. Solve integration of 1 divided by x square dx, integration of root x dx, integration of 1 divided by root x dx. So, solution. So, first is we shall solve this one, integration of 1 divided by x square dx. So, we all know that the standard formula of integration is integration of x to the power of n dx, that is equal to x to the power of n plus 1 divided by n plus 1 plus the constant of integration c. So, it has to be in the power of x raised to the power of n to apply the standard formula. But here we have it as 1 divided by x square dx. So, to apply the standard formula, first we shall simplify this 1 divided by x square and write it in the terms of x raised to the power of m. So, to write that, we shall use this rule of exponent, that is 1 divided by a to the power of m can be written as a to the power of minus m. So, 1 divided by x square is equal to, by this rule of exponent, we can write it as, the place of a you're having x, and the place of m, when you compare with the rule of exponent, we are having it as 2. So, therefore, we can write a means x raised to the power of minus m is 2. So, 1 divided by x square by this rule of exponent can be written as x to the power of minus 2. So, therefore, 1 divided by integration of 1 divided by x square dx is equal to, so by this rule of exponent we can write it as x to the power of minus 2 dx. So, now here you can apply this standard rule of formula for integration, that is integration of x to the power of n dx. So, what is n here when you compare it? N is minus 2. So, therefore, it is x to the power of n is minus 2 plus 1 divided by minus 2 plus 1 plus the constant of integration c. So, that is equal to x to the power of minus 2 plus 1 means minus 1 divided by minus 1 plus the constant of integration c. Again, so by this rule of exponent, a to the power of minus m is 1 divided by a to the power of m. So, therefore, x to the power of minus 1. So, in the place of m, you are having 1 can be written as 1 divided by x to the power of m. m is 1. So, x to the power of 1 is nothing but x. So, there is minus here. So, it is minus 1 by x plus the constant of integration c. Now, solve integration of root of x dx. We know the standard formula is integration of x to the power of n dx is x to the power of n plus 1 divided by n plus 1 plus the constant of integration c. So, that is x has to be raised to the power of n to apply the standard formula. So, solution. So, we know that root of x can be written as x to the power of 1 by 2. So, therefore, here you can write it as, instead of root x, you can write it as x to the power of 1 by 2 dx. So, now applying the formula. So, when you compare, so what you have n you have it as 1 by 2. So, therefore, it is x to the power of 1 by 2 plus 1 divided by 1 by 2 plus 1 plus the constant of integration c. So, now you simplify 1 by 2 plus 1. When you take the common denominator as 2, so it is 2 1s are 2, 1 1s are 1 plus 2 1 2s are 2. So, it is 2 plus 1. So, that is equal to 3 by 2. So, therefore, that is x to the power of 3 by 2 divided by 3 by 2 plus the constant of integration c. So, now we have this rule a by b divided by c by d. You can write it as a by b into d by c. So, therefore, I can write this numerator x to the power of 3 by 2 as x to the power of 3 by 2 divided by 1, because x to the power of 3 by 2 divided by 1 is x to the power of 3 by 2 itself, divided by 3 divided by 2 plus the constant of integration c. So that is equal to x to the power of 3 by 2 by 1 according to this rule into 2 by 3 plus the constant of integration c. So that is equal to 2x to the power of 3 by 2, 3 ones are 3, divided by 3 plus the constant of integration c. So this is the solution of integration of root x. Now solve integration of 1 divided by root x dx. So standard formula is x to the power of n dx. So we need in terms of x to the power of n. So for that we shall try to write that 1 divided by root x in terms of x to the power of n, x raised to some power of n, so that we can apply the standard formula. So how to simplify? So now root x we know that you can write as x to the power of 1 by 2. Now here we shall use the rule of exponent, that is 1 divided by a to the power of m can be written as a to the power of minus 1. So 1 divided by x to the power of 1 by 2. So in the place of m you are having 1 by 2, in the place of a it is nothing but x. So using this rule, so 1 divided by a to the power of m can be written as a means x raised to the power of minus m. What is m? M is 1 by 2, so it is can be written as x raised to the power of minus 1 by 2. So integration of root x dx, so according to the simplification we can write as x raised to the power of minus 1 by 2 dx. So now you apply the standard formula. So x raised to the power of n is x to the power of n plus 1 divided by n plus 1 plus the constant of integration c. So what is n when you compare with the standard formula? Here n is minus 1 by 2. So it is x to the power of minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus the constant of integration c. So when you simplify, minus 1 by 2 plus 1, so common denominator is 2. So 2 ones are 2, minus 1 ones are minus 1 plus the common here denominator is not there, means it's considered as 1 itself. So therefore 1 2s are 2, so 1 2s are 2, so it is 2. So minus 1 plus 2 is 1, so 1 by 2. So it is x to the power of 1 by 2 divided by 1 by 2 plus the constant of integration c. So that is equal to, so you can write that x to the power of 1 by 2 as x to the power of 1 by 2 divided by 1 divided by 1 by 2 plus the constant of integration c. So therefore you can write as x to the power of 1 by 2 by 1 into 2 divided by 1 plus the constant of integration c. So that is 2x to the power of 1 by 2. So according to the rule, which rule? A by b divided by c by d can be written as a by b into d by c. The following integral. First one, integration of 3x to the power of 4 dx. Second one, 2 divided by 3x to the power of 6 dx. Third one, integration of x plus 1 the whole square dx. To solve the integration problems, we shall use these two properties of integration and this formula of integration. So this property says that integration of f of x plus g of x dx, that is integration of summation of two functions, is equal to integration of the first function plus integration of the second function. It also holds good for if there is a summation of 3 function or 4 function or finite summation of certain number of functions. Then the second property is integration of a k into f of x, that is where k is a constant. A constant into a function is equal to, the constant is taken outside and you integrate the function. Then we use the standard formula for integrating that function, that is integration of x to the power of m is equal to integration of x to the power of n plus 1 divided by n plus 1 plus the constant of integration c. Now we shall solve the first problem, integration of 3x to the power of 4 dx. So we have this formula, that is integration of k into f of x dx is equal to, if k, there where k is a constant, you take the k outside and then you write the function inside that integral. So when you compare this 3x to the power of 4 dx with this property, so we can find that here what is k, when you compare k is equal to 3. So function, what is f of x? F of x is equal to x to the power of 4. So apply this property of integration here. So when you apply this property of integration here, the constant 3 is taken outside the integral. So you write 3 outside the integral and integrate that function, so that then you write integral of that function. So what is that function? Function is x to the power of 4. So x to the power of 4 dx. So now that is equal to 3 is constant. You know how to integrate x to the power of 4 dx using the standard formula of integration. So what we have, the standard formula of integration. Integration of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1 plus the constant of integration c. So when you compare this x to the power of 4 dx with x to the power of n dx, when you compare that, so you find what is the value of n here, n is equal to 4. So now apply the standard formula. So according to the standard formula, integration of x to the power of 4 dx will be x to the power of n plus 1. So what is n? N is 4. So 4 plus 1 divided by n plus 1. N is 4. 4 plus 1 plus the constant of integration c. That is equal to 3 into x to the power of 4 plus 1. 4 plus 1 is 5. So x to the power of 5 divided by 5 plus the constant of integration c. So this is how you integrate. Now we shall solve the second problem, integration of 2 by 3 x to the power of 6 dx. So we have this integration property, that is integration of k into f of x, where k is a constant. Then you take k outside the integral and you integrate that function f of x dx. So integration of 2 by 3 x to the power of 6 dx. First we shall identify what is k. K means constant. So what are constants here? In the numerator it is 2 is constant and the denominator 3 is constant. So what we shall do? We shall take the 2 by 3 which is constant outside the integral. So I will write 2 by 3 according to this rule of integration. The constant is written outside the integral. So 2 by 3 is constant. I am writing it outside the integral and write the function. So what is function? Remaining inside that after removing the constant. So it is 1 by x to the power of 6. So it is x to the power of 6 dx. So that is equal to, so now formula of the standard formula of integration is what? Integration of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1. So this is the standard formula of integration. So x to the power of n, we need it as x to the power of n, but here we are having 1 divided by x to the power of 6. So what we have to do? We have to write this 1 divided by x to the power of 6 in terms of x to the power of n. How can we write? By using the rule of exponent, that is 1 divided by a to the power of m can be written as a to the power of minus m. So we shall use this rule of exponent and write 1 divided by x to the power of 6 as x raised to the power of some power. So that is 2 by 3. By using this rule of exponent, 1 divided by a to the power of m can be written as a. What is a? Here nothing but x. M is 6. So minus 6 dx. So now we got it in this form, x to the power of n, x to the power of minus 6. Now we apply that standard rule. So that is x to the power of n is integration of x to the power of n is, so what is n here? N is equal to minus 6. So it is x to the power of minus 6 plus 1 n plus 1 divided by minus 6 plus 1 plus the constant of integration c. So it is 2 by 3. Simplify now. X to the power of minus 6 plus 1 is minus 5 plus the constant of integration c. So minus 5 is constant in the denominator, which can be multiplied with 3. So you get 2 divided by 5 3 is 15. So it will become minus 15. X to the power of minus 5, again using the same rule of exponent. So x to the power of minus 5 can be written as 1 divided by x to the power of 5 plus the constant of integration c. So this is how you integrate the second function. Now we shall integrate the third integral, that is integration of x plus 1 the whole square dx. So we know that the standard formula is x to the power of n plus here, but here you are having x plus 1 the whole square. So what we need to do is, first we need to simplify that x plus 1 the whole square in terms of x to the power of n, and then we shall apply the rule of integration and then integrate. So first we shall simplify that x plus 1 the whole square, so that we can get it in terms of x to the power of n, x raised to some power. So you know that x plus 1 the whole square, you can apply the formula a plus b the whole square. So that is nothing but a square plus b square plus 2ab. So if you apply this formula, in the place of a you are having x, in the place of b you are having 1. So we apply that formula, a square x square plus b square 1 square plus 2ab, 2 into x into 1. So you can write it as x square plus 1 square is 1 plus 2 into x into 1 is 2x. So x plus 1 the whole square can be written as x square plus, I'll write this 2x first and then write 1. X square plus 2x plus 1. So therefore integration of x plus 1 the whole square dx is nothing but integration of x square plus 2x plus 1 dx. So now here I'll apply the property of integration, that is integration of f of x plus g of x plus h of x. That is summation of 3 functions. If there is summation of 3 functions, so it is integration of first function plus the integration of second function plus the integration of the third function. So that is the rule. So according to this rule, so it will be integration of the first function x square dx plus integration of the second function 2x dx plus the integration of third function 1 into dx. Okay, so now that is equal to here integration of x square dx. Here I'll apply the property of integration. What is that property of integration? Integration of k into f of a constant into some function is equal to constant is taken outside and then you integrate that integral. So 2 is constant here. So 2 is taken outside the integral and write it as x dx plus integration of 1 into dx is dx, or simply if you want to write, you can write 1 into dx or simply you can write it as dx. Now you apply the standard formula, x to the power of m in the first integral. So what is the value of m? N is equal to 2. So x to the power of 2 plus 1 divided by 2 plus 1 plus 2. The second integral, what is the value of n? X to the power of, there is nothing, so it means it's x to the power of 1. So it is x to the power of 1 plus 1 divided by 1 plus 1 plus integration of dx is x, you know that, plus the constant of integration. So that is x cube, 2 plus 1 is 3 divided by 3 plus 2 x square divided by 1 plus 1 is 2. So here you can simplify, 2 get cancels plus x plus c. So that is equal to x cube by 3 plus 2 cancels, x square plus x plus c. So this is the